Now, let's see.
Looks
Oh, yeah,
good.
I can. All right. Okay. Well, I'll jump right in. I put this together as this uh, has I've been working with them, and they've especially in the last few years. I've been working on preservation, and while at the same time they've been uh, uh, transitioning and to the cloud. So there's been quite a shift, and I noticed, just looking at NOAA and USGS and the data centers, many of the earth science agencies are transitioning and are rapidly migrating to from repositories from physical and on-premise hardware to a commercial cloud environment. So the DACs, managed by ESDIS, they have been migrating archive and distribution operations beginning in 2019, and they're really accelerating to the point where all of their earth science data and information will soon be in the cloud. And so I know at ESIP, there's many or several active working groups that are uncovering and sharing bottlenecks and plans and archiving and cloud processing and distribution. So, and that's good to see. And I haven't personally uh, participated in those, uh, but that's I think the main thing there is that there are some things that I see at ESDIS that are being planned and that they were brought to my attention that really considering a long-term earth science feasibility for preservation, there's some immediate things that alignments that I would say are necessary among the earth science partners, in particular NOAA and USGS and other institutions that because we're all going to cloud native data. Uh, so I think the stewardship group here is, and is has a good. It's a good place to look at collaborative um, actions and things that we can do to address these alignments that I see we should look at. So let me go ahead. So um, so a little bit background. So the challenge here has been since the beginning of since the 1980s, and that the long-term satellite records inherently suffer from instrument drift and degradation and challenging or changing observation techniques. So it's well known that that's something for as far as the climate studies that needs to be addressed, and we need to make sure that we have the information and knowledge preservation of that kind of what's needed there for to enable that, and so that's how historically the NASA's preservation content specification, which was came working with ESIP back in 2011, and then was updated again in 2022. And it basically mandates preserving a complete technical context to allow scientists to continually remove biases and reprocess historical data sets. So, and the roots of that were from a 1999 workshop that used the 1980s case studies from the data centers and NASA, and to prove that preserving the full background metadata would allow scientists to uncover the multi-decade climate record. So that's and those case studies are in that report, and it's a good read if you want to find out where the specification came from. But the key takeaway here is that these, during this time, this 25 years, massive these storage advancements over the last 25 years allowed us to pretty much save everything from the raw data to all the way up to the derived products and software and documentation and so on. And so it sort of created a habit of having an endless raw data accumulation. So let's see. And so this is what's going on and what we've been doing at ESDIS at NASA. There's been a sort of what I would call an operational handoff, which mandates a structured kind of transition of these assets, which are these 8 different flows that they move from the principal investigator and the science team and the project mission operations facility to the DACs before decommissioning. So the 8 flows there are really the information of that goes into the checklist, and it ensures all the raw data, telemetry, processing, provenance, and each that they all get to the archive during operations, during the active instrument operations. So, and the DACs serve as a long-term repositories, active repositories during and after the mission. There is, in the distant future, there's the notion, and actually, there'll be a formal appraisal that's triggered by federal record schedules, and of course that appraisal, if they're approved, if the data sets are approved, and for example, they'd move to be the responsibility of NOAA's data stewardship. And so, for example, NOAA has evaluation rubrics now that the data stewardship maturity matrix, where the high priority permanently transfers to the agency archives. Let's see, and that's pretty much what I wanted to go. Okay, so what's changed or what's happening? And so one of the things that doing a little AI kind of search that came up with this death of the level 0 reprocessing, which basically is pointing out that post mission calibration, directly from raw sensor data, that is the level 0, is increasingly futile. So once the instrument's original science teams conclude their work and dissolve, the tribal knowledge of the raw telemetry nuances and the context-dependent instrument quirks are lost. So what do we do now? Today we rely on this top-down kind of homogenization. So instead, we have on-orbit cross-calibration and mathematical offsets and celestial and vicarious frameworks to stitch data across the missions without rebuilding calibration coefficients and reprocessing the level 0 data. So that raises this question, which is, as the EOS missions decommission shortly after the 25 years of multiple copies of this level 0 data, do we migrate these massive level 0 archives to the cloud? And that's at least that's one of the key. And I show these. I showed a couple of illustrations up here. The solar instruments, solar measuring instruments. This is where a case where, of course, each of the solar instruments had a slightly different, well, slightly, but in some cases, a pretty clear differences in their measurements, and then they were stitched together without recalibrating to form a permanent, long-term, consistent record. And then over on the right is the latest MODIS recalibration that in the latest version that really shows removing the instrument biases and some of the drift in the last few years. So it's just some evidence of what's going on, what we're doing today. So let's see, next one. So this just reminds us of sort of the old guard, the traditional backup 3-2-1 rule, where we secure data integrity and protect against data loss by making multiple copies and checking them periodically. And that's what ESDIS and the DACs have been following over the last 25 years. And of course, that's the 3 copies. This, standard there is just they have 3 copies to mitigate probability of independent hardware failures or media failures, and then 2 different media, the systematic and supply chain vulnerabilities, and then 1 copy offsite to protect against localized disasters and compromises. So, and of course, the backup copies have lower access rates or lower access depending on recovery time, and then and of course, a lot of highly used data sets were distributed across multiple facilities for data production. So that's so now what do we see happening in the cloud? For the cloud native lifecycle. So, well, the cloud evolution, there's a shift, of course, from facility procurements, just-in-time procurements for the mission towards a scalable usage-based model. Then there's also increase in processing efficiency. So faster on-demand process and scalable processing in the cloud, should reduce the need for intermediate storage. And then, of course, there's things like automatic versioning and multi-decadal storage durability now in the cloud. It eliminates any need for media rotation. And that's I think the thing here is there are these new risks come up where we trade localized physical disasters for vendor lock-in and centralized media control, and then of course we'll have to look at the narrow requirements for digital surrogate rules and how we're supposed to protect the integrity of these federal records. So, and so the agencies have more and more responsibility and longer responsibility. And so I'm looking at or would like to look at what life cycle changes we should expect and plan for in the cloud during and post-mission. What determines, for example, what determines temporary and permanent records? And so let's see, let me go ahead. We also have a situation where there's a paradigm shift for the Providence, where Providence records, for example, in the past now and up to now, the DACs, they were the single organization. They had they were responsible for all the provenance chain. So everything from the documentation software as well as raw and derived products. So, but that's going to move to a decentralized sort of a hybrid cloud system. And so, an example, of course, is the raw data may sit in one cloud, and auxiliary inputs like first guest fields and you know uh, uh, different kinds of uh, external uh, um, data, ground truth, and so forth. Uh, those auxiliary inputs are held at a separate agency like NOAA, and then the software algorithms on GitHub and metadata will be in the project specific libraries like or repositories like CMR and or flight project libraries. So the threat there is really that a single link, a single broken link there destroys the historical continuity. And so if a node experiences an outage or the links are gone, there's a format obsolescence like HDF. We can't run HDF readers or NetCDF. The entire data set can lose its scientific utility and historical continuity. So that's what we need to look out for. And of course, there are solutions, and I point to the OAIS Federation, which up at the top just shows two illustrations from the CC OAIS document. That just the one on the left, of course, is a single repository that represents, say, a DAC, and then on the right will represent where we have different organizations and different OAIS facilities that need to cooperate and with a common catalog. And so that's so of course the strategies then would be to develop a global DOIs for every element in the provenance chain, and then and then redundant or protocols that mirror the software or provide software in different places, and of course the CMR catalog, and then packaging the algorithms and HD readers in an environment so that they don't become obsolete or they can't be run to read the data. So let's see if I go ahead with the next slide. Then, oops. Okay, there. So I can't. I'm here to data stewardship because I think there's several things that we can do as far as outcomes that would contribute and help in the long run. So one, there's some targeted objectives that for example, we could define tiered architectures, establish what criteria for cloud storage tiering that matches or exceeds the 3-2-1 rule. And I know there's several extensions of that, but I think we really need to look at it from the perspective of Earth science and the Earth science data lifecycle. And that's the second one where we want to look at, life cycle governance, which actually focuses exactly on when to maintain things like their raw level 0 data assets versus calibrated level 1 products versus level 2 and level 3 products. Um, and so those are sort of some two main objectives. And then as far as deliverables, I think that to record findings by agency and institutional representatives. Uh, we would issue, or I would suggest we develop and issue a formal um, committee report, a cross agency report that would address both of these objectives. And then, the framework could basically be updating or revising the preservation content implementation guidance that was developed into a request for comments back in 22, and really needs to be updated. Uh, and let's see. Uh, and there's some ideas about what the impact could be, and certainly one is that the lifestyle will really help our data centers and as is decide what really needs to be retained after the EOS missions decommission. And second is what kind of backup requirements do we need in the cloud given the versioning capabilities and the long decadal durability, and so how many what and the other options they have for immutable backup. Let's see. With that, let me just one more, and then I had some thoughts. Of course, best practices. There's this sort of a, a standard or approach to that in stages, and of course it's these where we want to talk to the experts and at each of the representative data centers, and then capture that knowledge and then standardize the documentation, of course. But more importantly, the approach I've been thinking about is just brainstorming some of the systematic pain points across NOAA and USGS and NASA, and then and from their agency institution perspective. Um, and then I think if we had the opportunity to do some to do or conduct some deep dive stories, compelling experiences based on sort of the veteran missions like EOS decommissioning, that would really add the evidence that we need, that the best practice is workable and valid, can be validated. And the same goes with then lastly, just looking at some hybrid cloud backup strategies from maybe some more of the mature commercial technology in industry. So those areas, I think, are the three that at least came to mind in how to approach the problem. So, Peng, that's pretty much where I ended up, and I know I'd like to ask if there's any thoughts or questions that I can answer, or if I can't answer them, I can go off and find answers or make suggestions. But I think what I was thinking is that from here, it sort of go around and ask those that are here at the meeting if they had any similar kinds of, uh, well, I don't know, I guess approaches or pain points, or if they thought there was merit in pursuing this, especially. I know that there are the other ESIP groups working in the cloud, and I think they are developing their different approaches there, but I think the idea here would be to focus on these two in particular in preparation, and some the compelling events are that we're we've moved pretty much almost everything to the cloud. I know the documentation and software is now planned to move to the cloud, and pretty much most of the data is there. And then the EOS decommissioning is coming up in the next couple of years. So those are the two drivers.
Thank you so
Why?
much, John,
Okay.
for the excellent presentation. We'll open up the floor for question. Nancy, please.
Hey, John, how you doing?
I'm doing well. Nice to see you.
Good to see you too. So, to help you answer some of your questions, NASA does have a records retention schedule, and mission data is under Schedule 2 and Schedule 8. So that will help you decide what you do with that data, the level 0 data. You were talking about the death of level 0. At NOAA, original observations are permanent records, so we have to keep those and then send it to NARA when our community no longer wants them. So you should look to that.
Wait, maybe I missed something there. You said what do you save? The level 0? You actually save the level 0, or which? Okay,
We
and
do.
that and
Level 1B is probably better,
yeah,
but level 0 is the original observation. But
right.
so look into your records retention schedule. The other thing is, if you plan on removing or not migrating everything to the cloud, then there's an agreement with the CIOS-WIGIS group that any of these large agencies, if they're going to remove anything, then they let all of our partners know across the globe in case they
Right.
want. We've currently there's an effort to get all the AVHRR data together and get one single harmonious, homogenized record. So there is precedence for keeping data long-term and doing that work. So those were a couple things about the level 0 data. You also mentioned vendor lock-in with the cloud. Well, I will also say you've got vendor lock-in when you're on-prem, because you buy this huge system with these tapes, and so
Yeah.
either way you've got vendor lock-in, right?
Right.
How do we mitigate the risk involved in moving to the cloud and potentially losing data? That's one of the questions that I have. How do we do that? Because if we're only putting data out in one cloud sector, what happens when somebody accidentally removes something? It has gone poof now. You don't have an offsite copy to bring it back.
Right.
But I would be interested in talking about common pain points and
Okay.
working together on a paper.
Thank you so much, Nancy. Jennifer, please.
Hi, I'm Jennifer Shupp. I'm at the Texas Advanced Computing Center, part of UT Austin. And honestly, I would take a huge step back and reevaluate whether cloud was the right path, in part because of the vendor lock-in and financial costs, and because there are other resources. So, for example, at TAC, we just moved 14 petabytes of data from NCAR to Austin, and we're a backup site for them. You don't have vendor lock-in for tape because the tapes get redone every 7 years, so they don't age out. You've got choices there, and even if your leadership has decided you're moving to the cloud, you can still come up with alternatives. you can talk about tax services as being cloud-like. We sell them that way. We are something like 12 times cheaper than Amazon, whatever. And those numbers are public and known, and I've run them for other science teams.
Okay.
But the risk that you're looking at, and I won't say that you don't have them with academic partners, but everyone has seen how various cloud providers have changed cost models or had bits and
Yeah.
pieces turned off with no notice. And at least in academia, we're here for the science. We're not here for the business model. So, I don't know, some of I would kind of question a couple of the assumptions you have here. But I'm coming at this from a different background and a different point of view, and 25 years of my own of working with scientists and telling them that, we refer to the cloud as burning your boats.
Yeah.
You were there and you are stuck.
Federal
And that is,
agencies is a very unique use case, and your case is very, it's a different use case as well. It would be interesting to include that.
we cover science across the board.
Yeah.
So I mentioned the end card just because that's something we've done recently, but we've been supporting science teams for over 25 years ourselves, all across different use cases and different types of science. So,
Thank you,
and
Jennifer, for
we're
sharing.
not the only academic center that does that.
Yeah.
You
Thank you
know,
for sharing your
Well, I
thought.
would like to reach out to you, Jennifer, just because I want to make sure. I mean, I mentioned the main agencies, but like you said, NCAR it certainly is a partner in many respects because they provide. I know we use some of their data in generating products, so auxiliary data. So that's a piece of the puzzle.
That's wonderful. Team, go ahead. Thank you, Jennifer.
I really appreciated Jennifer's comment, but it seems to me like the strategy of replication is kind of calling on us to recognize vulnerabilities of institutions that we hadn't previously thought of as vulnerable. And the principle of having replication through a different means off-site is seems to me the like operational strategy that we need to be thinking going forward. Because I mean, I don't think 3 years ago many of us thought NCAR was like a vulnerable facility, and frankly, I absolutely sympathize with this issue with the cloud service providers would like to create a context in which we have permanent dependency on them, and we actually really need to have strategies that are designing at least use like have interoperability to the extent that there's migration strategies that are well kind of conceived before
Right.
too much dependency on any individual is developed.
Yes, and the 7 year migration. That's of course we've had to do that several times with level zero data that's in our archive from the EOS mission. So, and even though I can envision having to migrate from cloud vendor to cloud vendor, so that probably should be built into to a life cycle plan.
No, I'm sorry. What I was trying to say is you'll never be able to migrate from one cloud vendor to another because whoever you are with first controls your data. They will charge you for pulling things out, which at a level that you won't be able to afford, or they will change the underlying data structures so that if you are not paying them, you won't have access to your data at all. We've seen this happen in practice.
Okay, that's a good
So
point.
it's not it's not when we say vendor lock-in, we
There's that
we
is a whole
really,
different meaning.
yeah, it is you are locked in.
Hmm.
That's just we've seen multiple science groups get burned by this and have to pay exorbitantly to get out data that they didn't realize they would ever not have full access to.
That that's a really compelling observation. But has anyone looked at the extent to which Source Co-op's effort to use Azure and AWS in parallel for distributing their assets is resilient to this, or is this? I mean, I guess I feel like Source Co-op isn't really designed to be an archival resource in the same way that most of the assets that John discussed or Noah or but I think that I'm curious if anyone how anyone is engaging in this topic with a multi-vendor strategy with replication as an effort to offset the vendor lock-in problem.
I'm not familiar with that particular effort, but there is really no reason why the vendors wouldn't just each lock themselves down.
Well, I would.
They're on
So
their side. They're not on your
yeah,
side.
yeah. I think the one of the things that I think you could be considered is that you back up in a different vendor with a different vendor. And I don't know if anyone, hearing science, I'm not sure anyone is actually doing that yet, but that could be a reasonable approach to protection against kind of lock in. No?
No, because then you just have two different vendors which will hold you hostage. No, I mean it's serious. It's like, you put your stuff in one safe and you think, well, it'll be,
Yeah.
I'll put it in this other safe and other people hold the keys and will
Well,
only give
that's
you the key to either one if you go extraordinary, it's the
right.
same setup. And I'm sorry that sounds harsh and scary and bad, but we see so many science teams these days who are getting burnt by this. And it's not just the science teams, it's even, the academic enterprise people. I mean, how
Mhm.
many of us have had our home, the storage that our university or institution have, at first, Google was free. And then, oh no, Google isn't free. We got to move to Box. And then Box is free, except then Box wasn't free. And so we're, everybody's done these migrations over the last 10 years because, you know, it's
So
not, it's free like as in puppy, not free as in beer.
yeah. So I hear, uh, but in looking at some industry solutions, they do talk about a hybrid where there is an on-premise kind of backup, and that serves as the insurance against that kind of lockout. I don't know, but beyond just a simple Google search, but that's also a possibility. Um, but I do think that that's sort of where I wanted. That was one of the areas that we should or wanted to explore and see if others have looked at that because I think commercial like financial institutions uh, do that kind of backup security where they actually have a hybrid solution and now maybe
Backup security is a different story. I mean, so like if you're trying to do a backup for failure, that's a different story than what you were just talking about. So that's
um,
your 1, 2, 3, have one copy somewhere else.
right.
That having one copy somewhere else doesn't mean that somewhere else is somewhere you're going to want to take everything out of and replicate somewhere to be useful.
Um,
That's generally not I mean, that's generally not the use case. The one somewhere else is a recovery of a small portion of that, how that's generally planned in a data architecture.
yeah.
by people who do data architecture planning.
Yeah.
So
Okay.
it's a complicated problem.
Yeah, it is. Nancy, please.
It is a complicated problem, and John and I cannot do anything to change our organization's requirement to move us to the cloud. So the only thing we can do is provide them evidence that data has been held hostage by cloud providers. So if there's any information, any facts you can give us about, I don't know, volumes and how many, because I know NASA and NOAA, we've got, hundreds of petabytes of data. So are these, I had 5 terabytes of data, and because I didn't pay my bill on the first, they got rid of it, or they held it
No,
hostage?
they don't get
Or
rid
is
of it, but they can hold it hostage, or they can remove the easy front ends. I mean, that's what the current administration did to a bunch of NOAA data sets about a year ago, right? You could still access the data with command line, but the nice friendly portal front ends all got turned off.
that,
We've all
unless I
heard those
have,
stories, right?
unless I have the exact URLs or the groups or something like that, it doesn't help our case in changing anything.
Well, that would be one of the things I would like to include in what we do. The evidence is critical. That's basically what was done in 1999. And there was a lot of evidence given by the data, by that team. Which, Nancy, I think you were part of the team back then. The workshop.
Yep.
So yes, the evidence is important.
So back to Tim's comments about the organization's resilience. We had a WMO expert team. We had a discussion. We recommend that the members or countries should save their data in multiple members. And given my experience working with NOAA and NASA, I was like, no, there's no way we can do that because just sheer volume of the data is impossible. But for scientific teams that work with smaller volume, would that be something interesting to, beneficial to explore? Because, for example, we would never say NASA will be issue, or NOAA will be issue, or NCA will be issue, not be able to serve their data, or even, well, I'm assuming the data still be there. Is that something worth exploring? John, when you are looking into more of a cloud strategy?
Well, I don't want to say no because but I know the compelling thing that was presented to me by Chris, by the ESDIS project was this. They have multiple copies of level 0 data for 25 years, and they really, I think, generally, there's no expectation that we could really reprocess that, even a piece of it to the level that, and there's a cost. Of course, it's some of that's a cost and effort driver. So I think it'll be a long time before the smaller data sets would be compelled to change the 3-2-1 kind of transition, kind of
Yeah.
rule, old guard, if you will.
Yeah. I see Matt has his hand up. Go ahead, Matt.
That.
Yeah, hi. Thanks.
He's
This is
from
Matt.
NCAR.
Yeah, Matt Marinick from NCAR. I haven't really been involved with the NCAR work with TAC, but I know it's been really helpful. So thank you, Jennifer, for that, first of all. But on a different topic, John, in one of your slides, you had the OAIS model and kind of referenced that. And so this is maybe a bit of a naive question, but um, has the OAIS model been discussed on how it needs to evolve or how it relates to deploying preservation services in the cloud? And so maybe you could just expand on what you said in that slide. Just
Yeah,
naively looking at the most recent update to the OAIS model, it doesn't even include the word cloud, so maybe that's
no,
not part of its scope. But thank you for any
no, it
comment.
doesn't. You're right. It doesn't, um, and it really doesn't address the provenance kinds of areas. It really just treats everything like data, and it's left to the organization. Now, the interesting thing is the federation. They did that that part that's OAIS Federation. That I think is new and recently in the last few years documented in there. So they had a vision that beyond the single organization and a federated kind of. But the cloud itself, no, not that I read the last time I looked. So, which was
Yeah,
just recently, I didn't see anything.
yeah, thanks. And I know the OAIS is supposed to be somewhat, technology agnostic, right? It's a framework or a model that could
Yeah.
or should be implemented in various technologies over time. But maybe this is Nancy, I see your comment there. That's kind of what I was getting at there. But maybe there's an opportunity for some guidance, community guidance on this. What does it mean to be OAIS compliant in the context of the cloud?
Well, and in reading that and looking at most of the others, not too many folks talk about backup, the 3-2-1 strategy and how that should evolve. That's sort of a new area that I think the WIGIS folks have, and other the ESA Europeans have looked at some of that, but yeah, I don't know what's going on with OAIS and along those terms.
Yeah,
Yeah.
we got 5 minutes, 4 minutes left, and I think that's a good segue to the path forward. It looks like there's enough interest on this particular topic. Perhaps we can discuss whether, John, would you like to have your own smaller group? Then, make update on monthly data stewardship committee telecoms, so you can decide how often you want to meet, or you still like to have another meeting, continue to discuss it.
Well, I'd like to reach out to the folks that spoke here today and just kind of get you know well, now that we've sort of done an introduction, just get more feedback, if you will, one-on-one. So if that's all right with folks, I'll Nancy and Jennifer and Matt. And others, if just send me a note because I would just like to talk and see if there's a way, see how I can adjust things to make it more useful for them, for example. So
That sounds
because
great.
I do think it's a cross agency task and job. And I know as is, we kind of have to look down the road and want to make sure that, well, there's different areas where I think there's that we should have collaboration and we should have some alignment. And that's where I wanted to head. So if it's all right, I'll reach out to folks and then I'll get back to you, Peng, and maybe
Yeah, sounds wonderful.
together another
That
presentation.
sounds great. Yeah. And thank you again, John. And thanks everybody for attending today's telecom and discussing for the productive discussion. We won't have August meeting because it's very close to the July meeting, and then our next meeting will be September 14th. And John, I don't think you have issue with me link the slides to the meeting notes, and which I will do that after meeting. And feel free to reach out to him if you would like to get involved, and we'll probably would continue get update from John on our meeting. John, you may want to put your email in the meeting notes. That way people can, or if you have your contact information in the participate table.
It should be at the beginning of the slide.
Okay, that's wonderful. And I also would like to remind people, if you have not done so, put your contact information in the participants table. That way people can collaborate and reach out to you. And you feel free to reach out to me if you needed to contact anybody. And that will be all for today. Thanks, everybody. Bye for now.
Okay, thanks, Frank. Thanks, everyone.
Thank you.
Thanks, everyone.
Bye.